All right. Today we're going to continue with answering the question of how does Java code get into the hands of people to use it? And the one thing we talked about last time, and I had a little bit of a problem in class, I corrected that and posted the results online. But I want to take a minute here to look at how we create a jar file. And a jar file is a Java archive file. And what it allows you to do is, provided that you have the Java runtime engine installed on your machine, you can run any file that's compiled into a jar. In some cases, it might actually be a collection of jars, but let me show you what I mean. So I'm going to open up NetBeans, which we talked about last time as being one of the IDEs that you can use for Java development. And we brought in first GUI into here. And we can see that we have our package, which is edu loraineccc.zellers first GUI. It's sort of in that reverse URL format. And this guarantees uniqueness, because if every organization is going to only use their URLs are unique. And if they manage the rest of it, then any class can be uniquely qualified. All right, so we have all our classes in here. I didn't do, well, there's only one class in this case. If I go and run this, I can run this. There seems to be an error. I'm not sure. Oh, I'm not looking at the right thing. Yes, I am. Not find or locate main class first GUI. We have to go in here and under properties, specify that the when we run this, main class that we want is edu loraineccc first GUI. Now we should be able to run it. And sure enough, there it is. But we're not going to count on, people aren't going to have NetBeans unless they're Java developers themselves. So what we do is we can create a jar. And the jar we can run through, and when we compile it or build the project, it will produce a jar file. And if we look out under the project, under target, you'll see the jar file over here. That was created when we compiled it. If I open this up, that opens up the application. So I could deliver this jar file to anyone that has a Java runtime engine, and if they ran it, they would get my little application here. Or I can type in the temperature and convert it, centigrade to Fahrenheit, Fahrenheit to centigrade. Now, I wouldn't just deliver them that jar. There'd be a whole install program that created the proper folders and put the jar in the right location and created an icon for it and so on. So there's more to it than just delivering the jar, but the jar is the first step in deploying this. And that would be, would require every machine, every client that ran it to have the Java runtime engine as well as a jar, and any updates we made to the jar would have to deliver an update to all the clients. All right, and in order to do this, if you remember last time, I tried adding these lines of code in. I was missing a XML tag, and that is build. So this code that you see here goes after properties in this pom.xml file. And this is for if we're compiling with Maven. And and we just make sure that we have the proper qualified first class that gets run. Because remember, you could have in an application, you could have several classes that contain a main method. You have to specify when you run this jar, which one do you, which main method do you want? All right. There's a link for showing you how to create that if you use Maven. All right, now I want to show you two web ways of deploying Java applications. And as we know from before, web deployment has the advantage of the Java code runs on a web server. The client, therefore, does not have to have a JRE installed. As long as the web server can run Java, it's going to produce HTML for the client. So the client is going to get delivered HTML code. All the Java code is going to run on the web server. And if there's any change to be made to the Java code, it only needs to take place on the web server. It doesn't need to be sent to every user because every user gets a fresh copy of the web page every time they run it, right? And they're getting delivered HTML anyhow, which is the output of the Java code on the server side. So I'm going to run a couple examples here. One of them is a very simple example that simply takes and echoes the data back to the user. I did this for my Akron class. And if I run this example, that's why if you notice the package name is edu.uakron.java2. What we have is we have this. I can sketch it out on the screen. This is a JSP. With a JSP, we have an HTML document that submits data to a JSP page. JSP page is simply HTML code that contains Java. And this JSP code uses what's called a Java bean. And doing what you need to do. Now, this is a very simple example. All we do is we run the code, we accept some data from the user, and the JSP page simply displays out, sets the values of the bean and displays it out. So let's run this and see how this. So if I say for this example, right mouse and run, I get my HTML page. I look at the action of this page. Action of this page is to call userdetails.jsp. So my HTML page is going to call on the server userdetails.jsp. And in this case, if I type them in, and click that, all my JSP and Java Bean does is outputs the data. But again, in a larger example, that could take the data and do something with it. So the HTML, if you've taken HTML, this is just a very simple page with a form on it. The JSP is simply HTML that includes these JSP tags. Use bean. And we can set the properties. And we can get the properties and output them. If we needed to, we could do more things. For example, on an LC tuition calculator, we could create a bean that does that tuition, and we would set the properties of number of credit hours and residency code, and then ask for the property of tuition. A Java bean is a component that you can easily put into a Java page that you can set and get different properties of. In this case, I'm using the bean in this class, edu Java, Java 2 details. This sets the property of the bean, and I want to set all of them. That's what the asterisk means. What that will do is that will take everything from the form and will fill in the appropriate properties in the Java bean. So the HTML page has username, user password, and age. Those are all properties on the bean. And if we, as long as the names match up, or as the names, what I call them on the form, match up with the names that they're called in the bean, I can say set properties like that, and that will take everything from the form and fill in the properties from the bean without me writing a lot of code. And then I can get the different properties. If we look at the bean is like any class that we've developed so far. All right, a couple of characteristics of a bean. Number one, there is a no argument constructor for the bean. In this case, I haven't defined a no argument constructor, so the default constructor is available. Every property is made private. Every property has a get method and a set method. So here my properties are username, age, and password. I have a get method, that's get in the name of the property, a set method, which is set in the name of the property, and so on. If I do this, if I follow this convention, then I can plug that bean into my JSP page and say, I want to use that bean. I'm going to set all the properties, and that will set any property that matches up with the form fields. And then I can access those properties. And again, although this example doesn't do it, I could do more extensive things like do a calculation or something like that. I could save the bean in a database or something like that. Again, this is just a very simple example to introduce the concept of JSP pages and beans. So JSP pages are, simply put, HTML that contains Java. And some of that Java is likely to be in the form of Java beans. And beans are components that easily communicate with web pages. And you can define a bean, use it on a web page, set the properties, and get the properties very easily. All right. You can do more, though. You can call other Java code from within your JSP page. Let's go out here and look for a JSP example. Here's an example. Code that takes information from a locale and displays information about it. Here's an example of a registration page. We have our form that submits to this. We can grab all the names, all the fields from the form, and we can write Java statements to grab all that and register the user. Well, these are particularly good examples. Here's a kind of cute one. There's no bean involved, but it's simply one to tell you that you'll have, whether you have a lucky day or not, right? And allows you to run it and see. Let's go out and let's actually create this bean to show you, or this JSP page. Say I want a new JSP page. I'll call it greeting. It's in the web pages folder. And I'll paste this code in here. And what this does is this generates a random number, and that number will be between 0 and 1, and will include decimal points. If the number is greater than 0.95, in other words, 95% of the time, it's going to tell you you have a lucky day. Otherwise, it's going to tell you that, well, life goes on, and you're not going to have such a lucky day. All right. Then it outputs the URI to try again. That will just be a link back to itself. So let's run this. This will take us to our home page if we run it, and we can just type in the URL. Provided we spell it correctly. Well, life goes on. Isn't that my luck? Is that, oh, I stated this wrong. It has to be greater than 0.95. That means that 95% of the time it will tell you life goes on. And you can try again. There, finally, we're going to have a lucky day if it's over 95%. I misread that as a less than sign if it was less than 0.95. The whole idea of this, and what I want you to get from this, is that this is plain old HTML, and interspersed in it is Java code. And that Java code can be interspersed a couple different ways. One way is with these declarations where we can insert just Java statements. And again, these Java statements could be more involved in that. It could involve creating objects, doing really everything that we've done. If we had 2 or 3 more weeks in the course, we might create a JSP page that allows us to create a pizza order or something along those lines. But we can insert Java code this way into our page, or we can insert Java code through the use of the Java bean, which is simply a class that follows certain rules. That is Java JSP pages, Java server-side pages. Now, there's sort of a cousin to server-side pages called Java Servlets. And both of these, JSP and Java Servlets, both get compiled to be Java Servlets. So you come from a different direction, but you really end up in the same place. So they're really not a huge difference between internally how the two of them get executed. In this example, with the Java Servlet, if I run it, I get my HTML page where I can type in a temperature, and it will convert it from centigrade to Fahrenheit. So how do I do that? I have 2 classes. The one that does the actual work, the one that does the actual calculations, called convert, and the servlet, which is the UI. We had alluded to this before about keeping your UIs clean from having calculations in them. Servlets are the same way. They form the UI, in other words, how the user interacts with the system. They do not contain any of the business rules or business logic or the problem logic. All that are in separate classes. If we look at this example, we have an HTML page rather that submits a form that contains a field called centigrade. It calls the action of that form is example servlet. So that calls this example servlet class. And the example servlet class is just a plain old Java class who outputs HTML. This is sort of like the Reese's cup, right? You got chocolate in my peanut butter. You got peanut butter in my chocolate. All right. JSP is Java code inside of HTML. Java servlets is HTML inside of Java code. We have our basic Java class here, and its job is to output these pieces of HTML to the client. And other than that, we can do any sort of Java thing. Here we create an instance of our conversion class. We get the value from the query string or from the request of centigrade, which matches the name of it on the form. We create an instance of that conversion object, we convert it, and we display the output. If there's an exception, we simply output danger that there's an exception. When would there be an exception? If we entered in something that was non-numeric. Because this double parse double would fail and you would not get a number out of it. It would give an exception, which we are catching here and outputting danger. I don't expect you to be experts in these or be able to write them. What I do expect you to recognize is this is a way of developing a web app using Java. And again, Java is different than JavaScript. In this case, we have two models to follow, the JSP and the Java servlet. And even within a single project, they can be mixed and matched. JSP is where you have HTML code that contains Java code. Java servlets is Java code that outputs HTML and that has HTML intermixed with the Java code. What I want to conclude with today, and we'll do some wrapping up after this, is Android. Let me back up just a minute though. It may look like those things ran quickly and correctly and didn't take a hassle. Believe me, as students in my Akron class have found out this semester, configuring NetBeans and the Glassfish server, which is a web server that NetBeans uses, and all these other things can take up a lot of time and effort and can be very troublesome. This ran very slickly because I had this machine configured properly. And so, boom, I was able to run these things without any of a hassle. In many cases, though, if things aren't configured correctly, it can be sort of a puzzle to trying to figure out just exactly what went wrong and in trying to run a JSP or Java servlet. Similar you have with Android with Android stuff. Things have to be configured and installed properly for Android to work. I'm going to bring up Android Studio. In Android Studio, there is sort of the IDE. Well, it is the IDE that's used for Android development, much like Visual Studio is used for Microsoft .NET platform stuff or C# applications. Android Studio fills that role. in the Android world. Maybe. See if it comes up. There we go. Welcome to Android Studio. It was already running. Now, I'm going to create just a very bare bones example just to sort of show you how the architecture of an Android application. Excuse me. Okay, so I'm going to click New Project. And I'm going to click up just a basic activity. This, by the way, is covered in our Intro to Android class, CISS226, which is a good class to have and a good opportunity for you to use Java. Now, Java or Android supports two languages, Java and Kotlin. And Java was sort of the first language that Android supported, and Kotlin is sort of a newer language. But there's a lot of Android development already done that was done in Java. So chances are, if you have an Android application, it was probably written in Java. Anyhow, I'm going to create a basic activity. Go to Next. I'm going to put it on the desktop. Maybe. I'm going to call it CISS226 example, just so I can easily find the folder. Language of choice, I'm not going to choose Kotlin. I'm going to choose Java. The minimum SDK is you can put on any application what the minimum version of Java that this will run on. You can do that to eliminate a lot of problems because the Java language has changed, or I'm sorry, the Android platform has changed quite a bit from the first version of it. And if you pick that, your app will be able to run on approximately 98.8 of all devices. Go all the way back to this percent of all devices. I don't remember which one we had picked. There we go. And I'm going to click Finish. For even a small application such as this, an empty application effectively, there's a lot of files that get generated. And you can see those things flipping through as it's creating different files. It's also installing platforms, and because if you don't have certain platforms installed when you create it, it will install them for you. And we're done. And we're left with this application. Still doing some processing of it. This uses Gradle to control the compiling and deployment of the application. Generates with some basic code. We'll actually run this in a second as soon as the Gradle sync and compiling is done. Might have to download a few things. As with JSP and Java servlets, configuration is important. An Android application involves a bunch of components talking to each other. And those include components in Gradle. Again, the system is used to control compiling and deployment of these things, Android applications. Different versions of Android, different versions of objects, and so on. You can actually run this using an emulator. Just in case you don't have every kind of Android device, you can run an emulator that will test that. That being said, you should also run it in an actual device before you're ready to put it out on Microsoft, not Microsoft, Android store. Just for this very simple empty application, look at all the stuff it created. It created an Android manifest. It created several classes, first fragment, second fragment, main activity. It created some test code that we could potentially use. It created a lot of resources, including drawables, layout files, menu files, icons, so forth, value XML files. A lot of this data that controls the application are contained in XML files. And sure enough, we can look out to where this got generated out on disk and see all these files. Along with files that were created for Gradle, that is controlling the compiling of this. A lot of files that are involved. This gets complex. If I want to run this, I can go and say run this application. Even though there's no Android device detected, I can run this. It'll go do its thing and run it on an emulator. Connecting to the emulator there. And we have our little pretend Android device which fires up. That you can do things to, like rotate it to see how it handles rotating the screen, and so on. And pretty soon we should see our application. This acts just like an Android device. Therefore, we can see the settings and so on. Hello, first fragment. Second fragment. You can put code in there for when you click on that. Put code in there for our settings and so on. So it gave us this shell of a program. Now, we look at this, we're going to see Java code. A lot of the challenge in learning Android development, in addition to the challenges that you face in Java, is understanding the Android framework. For example, this main activity extends at compat activity. And therefore, understanding the methods that are available and the properties that exist for that component are important. Here we have an on-click listener that we're setting, much like we do in our UI. So when the button is clicked, we want it to do something special. As you can see, the rest of it is Java code. I mentioned the XML files. XML files come into play a couple of ways. First of all, we have XML files that control the main layout. We have XML files that control the menu. Put menu items here. Remember, we had a menu item for settings. I can add another menu item for notice this doesn't allow us to type in the name of it. It refers to us to a string file. So that's how we would add a menu item at any rate. Action settings, the word settings is actually in the string file action settings. What does the string file do? It contains all our string constants. So that message that said, hello first fragment, hello second fragment, first fragment, second fragment, action setting. All these come from this file. That's a really important feature of Android development, because then if we want to change the wording of a label on a page or something, we only need to change it in the XML file, and the change will be made throughout the system. It's also very valuable because you can actually have different string files for different languages. So you could have a string file for United States English, you could have a different string file for French, or Arabic, or any other language. And you would then create that string file and put in the proper translations for those terms. And if the user's Android device was set to use one of those languages that you had a resource file for, it would automatically pull the labels from that string file and not from the default string file. There's a lot going on in Android, and it might seem overwhelming at first, but it is a very worthwhile platform to learn as mobile programming and mobile device programming becomes more and more important of a thing. All right, let's talk a little bit about the way the rest of the semester will go. This is my last lecture. So there will be no lecture next week, and there's no lecture on finals week. I have slightly expanded office hours this week and definitely expanded office hours the following week. In addition, office hours during finals week, which starts December 5th, are by appointment only. You have to make an appointment if you want office hours. Over the next week or so, I'll be posting an announcement setting like the final deadline to get any assignments in, and having information about the final exam in this class, including when it will be available and so on. The final will be online, so please keep your eyes open over the next week or so for those announcements and that information. So key things to remember: no class next week, no lecture next week. Do take the advantage of the office hours if you have questions or problems with anything, and keep your eyes open with some very important announcements concerning the end of the semester. That's all I had today. I hope you enjoyed the class. I enjoyed teaching it. I'm sure I'll come across some of you again and possibly see some of you in the office hours.